Okay, so lesson 20 is on exponential and logarithmic equations. So there's several ways that you can solve logarithmic and exponential equations. So I told you about the girl that solved things multiple ways on the test, and I was like, oh, that's great, that she really understands logarithms if she's able to do it all the different ways. Okay, so one of the ways is using what the book calls the one-to-one property. So if you have something like 3 to the x minus 1 equals 3 to the 4, you can say that the powers x minus 1 is equal to 4. Or if you have log base 5 of x plus 2 equals log base 5 of 10, you can say x plus 2 is equal to 10. And then solve from there. The second way is to write an exponential equation in logarithmic form or a logarithmic equation in exponential form. So I always say, when in doubt, switch forms. And number 3, in order to drop a variable that's contained in an exponent, we need some kind of logarithm. So we can take like the natural log of both sides or log base 10 of both sides. You can really take any log that you want. So for example, if you have 5 to the x equals 4 to the x plus 2, you would have to solve that by taking some kind of log on both sides. So I would just take the natural log of both sides. So I think I told you guys last year, if you were in my class, whoops, natural log of 4x, 4 to the x plus 2. That when I first taught logarithms, it was when I was teaching at IU. There was a class called MO25, which was Precalculus. And I tried to make it really easy on my students, and I was like, oh, if you have something like log base 5 of x minus 1 equals 2, I tried to say, oh, you remember that rule where if you have 5 raised to the log base 5 of 8, it's all equal to 8? Do you guys all know that rule? So I tried to get fancy, and I was like, well, I'm just going to do 5 raised to both sides. And my students really liked that. They were like, oh, if I do 5 to the log base 5, then those will cancel, and that leaves me with x minus 1 equals 5 squared, right? Did you guys see that? And with the same explanation, we did things that were like 4 to the x plus 3 equals 7, I was like, oh, well, do you remember the rule that says if you have log base 4 of 4 to the x, it's equal to x, right? The log base 4 and 4 cancel. Do you guys all know that rule? It's the same thing here. So we could do log base 4 of both sides. And I thought I was really sneaky, and I was like, look at this nice way that I taught my students. It's just a real easy way to remember this. So we had x plus 3 equals log base 4 of 7 then. And they liked it, and they did really well on my test. And then they got to the midterm, which I did not write, so all the midterms for MO25 students were the same, and the teacher freaking put this on the test. And I was like, no, because then they panicked, and they were like, wait, should I do log base 5 of both sides, or should I do a log base 4 of both sides? Does that make sense? They didn't know. They were like, I don't know how to approach this problem because, you know, Jenny taught us that if we had this, then we could just do log base 4 of both sides to clear that 4 raised to the thing. Does that make sense? So I failed my students. I only taught them one way, and I should teach you guys multiple ways. So we're going to talk about lots of ways. All right, so on this first one, so if I have 10 to the 2x equals 5, I can solve this multiple ways. Okay? Can I get them so that they're the same base with a 10 and a 5? No. If I had like a 5 and a 25, I could, right? 25 is like 5 squared. 10, I can't do that. Okay? So I'm going to take either the natural log of both sides, or I'm going to switch forms. So let's say I switch forms. It's going to look like log base 5 of 10 equals, oh, I did it wrong, didn't I? Log base 10 of 5 equals 2x. Do we see? 10 to the 2x equals 5. Okay, and log base 10 is something that's on my calculator. It's just log, right? So I can put in log 5 on my calculator. And then I can divide by 2. So my answer would be log 5 over 2. Okay, so I asked you to find the exact solution and the solution to 3 decimal places. That is what we call the exact solution. So if I want to find it rounded to 3 decimal places, I put it in my calculator. So I do log of 5 divided by 2. So I get 0.349. So I have both solutions, okay? So we're going to start doing more of these exact solutions in pre-calc. In Algebra 2, I let you guys round it to 3 decimal places every single time. I'm going to ask for both. All right, so that's one way that I could do this problem, but there's lots of ways that I could do this problem. So if I had 10 to the 2x equals 5, I could do log base 10 of both sides, right? The log base 10 and 10 would cancel. I'd get 2x equals log of 5 still, and then from there it would be the same. But how else could I do this problem? I could really do any log of both sides. So I could do like natural log of 10 to the 2x equals natural log of 5. That allows me to pull the 2x to the front, and then I divide. So I get natural log of 5 over natural log of 10 equals 2x. This is why the change of base formula, which you guys learned in the last section, do you guys remember the change of base formula? That's why it works. So if I have natural log of 5 over natural log of 10, I could write that as log base 10 of 5. Do you guys see that? I could have taken any logarithm of both sides. I could have done log base 100. I don't know. It doesn't matter as long as I do it on both sides. Do you guys understand what I'm saying here? Okay. I'll get rid of this because it looks gross. All right, so let's try the next one. So I'm going to add the 2 over. So I get 18. And I'm going to divide by 9, so I get 2. So x then is equal to, I would then take the natural log of both sides. Sorry, I get a little ahead of myself. So x is equal to the natural log of 2. That would be our answer. If you wanted to find it rounded to 3 decimal places, you would just quickly put in natural log of 2. It'd be 0.693. Are there other ways that you could do this? Sure. If you didn't know that you could take the natural log of both sides, you could switch forms and say log base e of 2 equals x, right? And then log base e is natural log. Natural log of x equals 2. Same idea. All right, so let's try the next 2. Subtract the 4 over. You guys trying these along with me? So I have 3 to a power equals 4. I can then do whatever you want. So I think most of the time, once you get better at these logarithmic equations, people just start taking the natural log of both sides. Is that the method that you guys like? I think most of my students don't like to think about switching forms. They're scared they're going to make an error. So if you just want to do the natural log of both sides, we can then pull that power to the front. So we're going to have 5x plus 2 times natural log of 3 equals natural log of 4. So I could do one of two things. I could multiply the natural log of 3n, or I could just divide it to the other side. Personally, I like dividing it over. I'm not dealing with like lots of natural logs. So I would have natural log of 4 divided by natural log of 3. So think about things like multiple choice exams. How might this be written with logarithms? If I was going to combine it with only like a log of just one thing, not just one log, like log written one time, what would it say? Yeah.
Log base 3 to 4.
Yeah, it'd be log base 3 of 4. Does that make sense? Do you guys see that with the change of base? So just kind of keep in mind what things could look like. So we're going to have our natural log of 4 over natural log of 3. We're going to subtract the 2 over, and then we're going to divide by 5. This is kind of a weird way to have your exact answer, right? It's like a fraction within a fraction. So that's when you might write things as log base 3 of 4. Or instead of dividing by 5, what could I have done to make it a little bit nicer? Yeah, multiply by like 1/5, right? That way it's all on like, there's not a fraction within a fraction. Does that make sense? So like the most simplified form might be something like 1/5, sorry, not natural log, log base 3 of 4 minus 2/5. It might look like that. Do you see why math teachers like you to round to 3 decimals in the end? So when I'm grading, I don't have to look at all those different forms. Will I? Sure. But do I have to? No, because then I'm going to ask you to round to 3 decimal places. So you would just find that on your calculator. So I'd probably do the natural log of 4 over natural log of 3 instead of going to find my log base button. This calculator doesn't have a log base anyway. I'd subtract 2, and then I would divide by 5. So negative 0.148. Okay, makes sense? All right, so number 4, it says this uses what your book calls the one-to-one property. So it's when you try to get things to have the same base. So if you recognize that 25 and 125 can both be written with a base of 5, so 125 is 5 cubed, 25 is 5 squared, then you're good to go on this problem. So I have 5 cubed raised to the 3x plus 7 has to equal 5 squared raised to the x plus 14. And we know our laws of exponents say that if I had like x squared raised to the 5th, I would multiply those powers, right? And have x to the 10th. That's what we're going to do on this as well. So we're going to multiply our powers. So we're going to have 5 to the 9x plus 21 equals 5 to the 2x plus 28. And we just set our powers equal to each other. So we say 9x plus 21 has to equal 2x plus 28. So 7x equals 7. So x equals 1. Okay, and you can check, you could plug back in 125 to the 10. You could see if that's the same as 25 to the 15, and they end up being the same. All right, do we feel pretty good with exponential equations? All right, let's try some logarithmic ones. Oh, I guess we have this one as well. How would I set this one up? So 8 I would rewrite as 2 cubed and 16, 2 to the 4th. Could you do other things? Yeah, you could do like 4, but it's weird. Because in order to get 8 by starting with 4, it would be like 4, take the square root of it to get 2, and then raise it to the 3. Like, do you want to do fractions? No. Like, have I seen people solve it correctly doing that? Yeah. Do I think it's weird when I'm grading? Yeah. I'm like, why did they make it so hard? So don't do things like that. So use 2's. All right, so logarithmic equations. So it says, no, always check your solution in logarithmic equations. So sometimes you have like the log of a negative number, which is bad. You can't take the log of a negative number, or 0, right? So maybe I should say, or 0. All right, so find the exact solution of the log equation and approximate the solution to 3 decimal places. So a lot of these you won't have to approximate. You're just going to have like nice fractions in the end, or nice numbers in the end. So in this case, if I have log written, what's its little subscript? 10, right? So we're going to write a little 10 in. And this is set up so that I can quickly change forms. So I can change from logarithmic to exponential. So I do 10 squared equals 3x plus 5. I get 100 equals 3x plus 5. I subtract over, and I divide. So my answer would be 95 over 3, which we can leave like that. Or if you wanted to do an approximation, you could do that. You would just do 95 over 3. I should know what this is. 31.667. Easy? We like those? Whole test was just that, right? All right, so this one, we don't have the logarithm isolated. So I'm going to add the logarithm to the other side. So I'm going to have 2 equals natural log of 3 minus x, and then I'm going to switch forms. So I don't know why we decided that we were going to write things as natural log instead of log base e. It really confuses my students. I don't know, they just did it to confuse high school students until the end of time, I guess. I don't know. So there is a subscript there. It's an invisible one. What is it? What little number is down here? E, right? So if you need to write it with a little e, that's fine. Or you can write log base e. So when I switch forms, it's going to be e squared equals 3 minus x. So I get e squared minus 3 equals negative x. So x equals, it's like negative e squared plus 3, so I'm going to write 3 minus e squared. Okay, and I check. So I'm like, well, what is 3 minus e squared? So I do 3 minus e squared, and I get negative 4.389. So I told you to be careful, because sometimes when you plug things back in, you might get a negative answer. And this is especially true if you have a lot of negatives. Like if you're getting negatives, you're like, oh, maybe I should really check this. But in this case, if I check, I'm plugging into 3 minus x, natural log of 3 minus x. So if I have 3 minus a negative number, is that okay? Yeah, it's okay. I have the natural log of a positive number now. So this actually works out. So that's our answer. All right, and what's the first one? Okay, the 31.667. Yeah, I didn't get a negative there either, so we're good. All right, so far so good. Any questions so far? Review of Algebra 2, you're feeling good about this? We did a lot of this in Algebra 2. All right, so this one I have lots of logarithms, so I need to combine. Okay, so I'm going to combine the two that are over here. And I know I can do that because they're both like log base 2. They're the same subscript. So I can combine into log base 2 of what? 3x. Remember, I multiply, right, when I combine, when I had addition between them. And then same thing here. This is going to be log base 2 of 5x minus 10. I'm going to multiply those as well. So could you do things here like you could subtract over and you could divide them, set them equal to 1, but that's really complicated. So what are we going to do here? Yeah, set them equal to 0, I guess. Yeah, I'm just going to say 3x equals 5x minus 10. Right? I'm just going to solve it. I'm using that one-to-one property. So I get negative 2x equals negative 10, so I get x equals 5. And then I go back and I make sure that I never had like log of a negative number or 0. Was I good? Yeah, with 5, it's totally fine. So that's our answer. All right, so this next one, I can bring the 2 up as a power if I want to. But again, overcomplicating things. We don't have to do that. We can just divide the 2 over. So if I divide 2 over, I get log base 5 of 3x equals 2. So 5 squared equals 3x. So 25 equals 3x, which means x is equal to 25 over 3. What is that, like 8 1/3? So if you found the decimal approximation, it'd be like 8.333. Still feeling good about this? All right, let's try some harder ones. All right, so I have log of 5x plus log of x minus 1 equals 2. So I am going to combine my two logarithms, but this time when I combine, it's going to be a little messy because I'm going to have 5x multiplied by x minus 1. So I get log of 5x squared minus 5x. Okay, so I switch forms. So my subscript is like a little 10. So I do 10 squared equals 5x squared minus 5x. So I have 100 equals 5x squared minus 5x. So I have 5x squared minus 5x minus 100 equals 0. And Greta's realizing that she has to factor, and she's moaning and complaining about factoring. Is that what's happening?
No, I was actually excited.
Oh, you were excited about it. Oh, God. I've worked in lots of factoring for my geometry students. They hate it. I'm like, geometry shouldn't just be like, oh, I'm going to set this equal to this, and it's x equals 5. Like, that's easy. We don't need that. We need like x squared minus 5x equals 6, right? All right, so anyway, so we pull out a 5. And we factor. So we have x minus 5 and x plus 4. So we actually get two solutions. So we get 5 and we get negative 4. But we go back and we check. And one of them works, but one of them doesn't. So what's bad? The negative 4, because we had 5 times negative 4 would be log of negative 20, right? Same with the next one. Log of negative 4 minus 1 would be log of negative 5. We can't do that. Can't take the log of a negative. So that's out, so our only answer is x equals 5. Okay, so same thing on the next one. So we're going to combine as much as possible. But in this case, I have log base 4, log base 8, and log base 64. So we really can't combine those into a single logarithm because they don't have the same bases. So this is when panic ensues, and you guys are like, what? What do I do? And then you look at it a little closer, and you're like, oh, I can do this because this is a number, right? And this is a number. Nice number. Let's find them. So if I have log base 4 of 16, what number is that? 2. We're good there. How about this one? Ooh, tricky. 64 raised to something equals 4. Not 3, close. 1/3, right? Do you guys see that? Because you're taking the cube root of 64 to get to 4. Now, could you have found that in other ways? Like you could write this as 4 cubed to a number equals 4 to the 1, and you could say, oh, 3 times a number equals 1. I don't know, I'm using boxes instead of x's, but you know, you get what I'm saying. But yeah, it equals 1/3. And then we continue solving. This is definitely a pre-calc type question. So we're going to subtract the 2 over. And you can all do 1/3 minus 2 without a calculator, correct? 1/3 minus 2 is 1/3 minus 6 over 3. Depends on the day. Monday mornings, not so much. Yeah. So 1/2 minus 6/3 is going to be negative 5/3. So I have negative log base 8 of x plus 5 equals negative 5/3. Yeah, let's get rid of that negative. That's gross, right? We need to get rid of the negative. And now we switch forms. So we have 8 to the 5/3 equals x plus 5. And you're thinking, Mrs. Cox, would you put this on the non-calculator section? And I say, heck yeah, I would put this on the non-calculator section. This is all stuff you should know. So 8 to the 5/3. What is 8 to the 5/3? Well, it's the cube root of 8 raised to the 5th. 2 to the 5th, which is, what are you guys doing on your fingers? What is it? Do you know 2 to the 4th? 16. What's 2 to the 5th then? 32. So we get 32 equals x plus 5. So our final answer is x equals 27. That's it. You would have gotten all the way there and said 29 on the last step. Oh, yeah. That's bad. All right. So that's definitely a pre-calc type question. I'm testing all of your skills in Algebra 2. I'm testing that you know how to raise things to a fraction, right? How you find 8 to the 5/3. I'm testing whether or not you know how to combine fractions. 1/2 minus 2. Do you guys know how to do fractions? Yeah. Did you know how to do log base 64 or 4? That's a tough question. It looks easy, but it's actually pretty hard. All right, this is another pre-calc type question. Because we have e to the 2x minus 3e to the x plus 2. And this says it's an equation of quadratic type. We did equations of quadratic type in Algebra 2. It was called W substitution. Do you guys remember W substitution? Right, when I replace things that look like x plus 3 to the 4th minus 5 times x plus 3 squared minus 6 equals 0. And I said, oh, let w equal the x plus 3 squared. Do you guys remember that? And then you're like, oh, this becomes w squared minus 5w minus 6, which is now a quadratic equation. Brooke did not do that in her Algebra 2 course. Yeah. All right. The rest of you guys have seen it. I know you have because it's in the notes in Algebra 2 at university. All right. So we want to know how to solve this. So give me a guess. What do you think our w is going to be? E to the x. Let's try it. So if w is equal to e to the x, what do I get when I do w squared? Well, it would be e to the x squared, which is e to the 2x. We multiply, right? We multiply those powers. So that's good for us because this becomes w squared, right? And this is w. So we end up getting w squared minus 3w plus 2. That's what we wanted. We wanted to create it, so, or make it, transform it so it looks like a quadratic equation, right? It's a quadratic equation now. Do you know how to factor that one? Yeah. Yeah, w minus 2, w minus 1. Perfect. So we get w equals 2 and w equals 1. But don't forget, we're not solving for w, we're solving for x. So e to the x is equal to 2 and e to the x is equal to 1. What do I do in order to solve for x? Natural log of both sides, right? So I do natural log of e to the x equals natural log of 2. So I get x equals natural log of 2. In this one, same idea. I get x equals natural log of 1. But I don't leave it as natural log of 1. Natural log of 1 is what? Oh, man. Yeah, it is good. Because log of 1 is always 0. Log base anything of 1 is 0. Because you're saying e raised to what power gives you 1, right? It would be 0. All right, so those are our two answers. We get natural log of 2 and we get 0. Are we smart enough to do this without doing a w substitution? Would you be able to go straight to e to the x, like that? E to the x minus 2, e to the x minus 1. You can do it without a w substitution. You just factor it, yeah. That's all we're doing. Right? You guys see how e to the x times e to the x makes e to the 2x? E to the x times e to the x, add the exponents. Right? Outer and inner, negative 2 e to the x minus 1 e to the x makes this. Last, negative 2 times negative 1. So you could just go straight to that without doing the w substitution. All right, so how about on this one? We are also going to factor this, but we're not going to factor with like e to the x times e to the x, like in our two parentheses. Do you see what's true for this? We have e to the x. Yeah, e to the x is a GCF. So we pull an e to the x out. When we do, we get x squared plus x minus 2. We can then factor the x squared plus x minus 2. It factors into minus 1 and plus 2, right? So x minus 1, x plus 2. See how the outer and inner swoops combine to be positive 1x, and the last make negative 2. We then set each piece equal to 0, but sadly that e to the x gives us nothing. Because if I have e to the x equals 0, e to some power equals 0, it doesn't make any sense, right? So you can take the natural log of both sides, you'd have natural log of 0, which is bad. This is all giving us nothing. So our only answers are 1 and negative 2. All right, still with me? All right, it's about to get real weird. You guys hate this lesson, don't you? You're like, I was feeling so good about it at the beginning, Mrs. Cox, and then you got all these weird ones. All right.
Would negative 2 not work?
It works because it's not a logarithm, so you can still plug it in. It will work. All right, so let's do a little simplification. So I get e to the x minus 7, e to the negative x equals, and I multiply the 2 over, so I get 6. Do you guys know what a negative exponent means? Like if I gave you x to the negative 2, what is it? It's a fraction. It's 1 over x to the positive 2, right? So let's write this so we can see what we're going to do next. I'm already realizing I have the wrong sign on this, but let's make this a plus. I think I messed it up. I'm making that a plus. I'm hoping that works. No, dang it. It doesn't. Don't make it a plus. I'm going to change this problem eventually because it doesn't factor, but I'm going to wait to figure out what I'm going to change it to. All right, so anyway, so I have this. Like over e to the x. What would you guys do if I gave you an equation that's like x over 4 plus 1 over 8 equals 3x minus 2 over 4? What would you do? Yeah, and you'd multiply through with that least common denominator to clear the fractions. Can we do the same thing here? What's our least common denominator? E to the x. So I'm going to multiply everything through by e to the x. When I do, I get e to the 2x minus 7. Oh, yeah, it does work. Yay, my original problem did work. It's overthinking it. Equals 6 e to the x. And we subtract that 6e to the x over, and I write it so it's e to the x. I sneak it in the middle, minus 6e to the x minus 7 equals 0. And now it looks the same as the problem we already did, the one that was the quadratic type. So if you feel like you need to do a W substitution, go for it. If you can factor it without a W, try it. Okay, go ahead and try to factor without that W. Did you guys get e to the x equals 7 and e to the x equals -1? So when you take the natural log to solve, we get natural log of 7, and this one becomes natural log of -1. That's bad, right? That didn't work. Can't do the natural log of -1. Guess I should do like parentheses around the -1. Can't do the natural log of a negative. It has eyes in it. Yeah, Greta's like, hey, I tried it on my calculator, it gave me a number, but it's because remember when I taught you guys how to do the things with I? Like, remember how I taught you you could do this on your calculator? Once I made you do it by hand for 2 years, I taught you how to use your calculator. So you guys set your calculators in a plus bi form. So when she did the natural log of a negative, it gave her an imaginary solution. So can you do it with imaginary numbers? Strange. All right, so we get natural log of 7 for our answer. And then same idea on this one. So now I just have 7 to the x's. So it works out the same. It's kind of the same process, though. I have 7 to the x plus 7 to the -x equals, and I multiply over and I get 2. And I write it so that I see my fraction. So I'm like, oh, that's 1 over 7 to the x. So then I can multiply everything through by 7 to the x. But I did this example because every year I have students that are like, oh, it's going to be 49 to the 2x. And I'm like, not quite. All right, so if you have 7 to the x multiplied by 7 to the x, it's 7 to the 2x. Now I could write that as 49 to the x. Did you guys know that's the same? Because 7 to the 2x could be written this way. But for us, we're just going to write it as 7 to the 2x for now. Okay, but I cannot write 49 to the 2x. That doesn't make any sense. All right, so anyway, it becomes 7 to the 2x plus 1 equals 2 times 7 to the x. Can I write 14 to the x? No, right? So I subtract over. And this is one where people really do, like, using a w sometimes really helps on this. Because what we have is, like, w squared minus 2w plus 1. It's just kind of hard to see that because all those 7s. So it factors. It factors into 7 to the x minus 1 times 7 to the x minus 1 equals 0. So we get 7 to the x minus 1 equals 0, which is 7 to the x equals 1. What's x? You should know at this point right here. It's 0. 7 to what power gives you 1? It should be 0. But if you didn't know, you could do natural log of both sides, right? Natural log of 1 is 0, so you get x equals 0. Natural log of 7 to the x. I guess I would have to do x times natural log of 7. Anyway, you get x equals 0. That wasn't a very interesting one, was it? All right, and these last ones involve other logarithmic equations. So there is actually, you know how we use logarithms for like earthquakes, like the decibel scale, anything that's scaled, pH scale. Did I say decibel? I said decibel, but I meant like the Richter scale. So decibel scale, Richter scale, pH scale, anything that's scaled, we'll use that. And there's also something called the law of forgetting. So if I told you right now that you guys were going to take a final exam on geometry, how would you feel about that? Would you be like, I don't think I want to do it? Would you do okay? Probably, because you're a couple years out. You'd probably do all right. But if someone asked me, I'm old, if someone was like, hey, Mrs. Cox, I heard you took French in school. How about you take your French 4 exam? I would be like, no. Like, I cannot take my French 4 exam. I've forgotten all of that. Same with like econ or history. Like, I would not do well on those exams because I'm a little bit further out of high school than you guys are, right? So this is used as logarithms. So it's called the law of forgetting. So we can do this problem next time, but it's kind of interesting. All right, so